I welcome you to this lesson. I am teacher Katimbo Richard, teaching mathematics. And in the previous two sessions, we talked about set concepts as a topic, and we are continuing with the same set concepts. This time round, looking at probability within the set concepts. And the question is, what is probability as part of P6 term 1? Not forgetting to mention that in your workbook, that probability will be found on page 26 all the way to page 34. If you don't have a copy yet, I ask you to hurriedly reach school and acquire yourself a copy so that you follow these sessions properly. So, what is probability? Probability is the chance that an event will happen. Probability is the chance that an event will happen. It is, on the other hand, known as chance. So when one asks you for a chance, then you answer as though you have been asked for probability. It should be noted that probability ranges from 0 to 1, and so the least probability is 0, and the greatest one is 1. The rest are fractional, meaning they are parts of a whole. Which fraction must be a proper one, like 2 out of 7, like 3 out of 9. That is if the numerator is actually less than the denominator. So we shall never have any probability that's more than 1. So other kinds of fractions, apart from proper and probably the decimal, the rest are not called for in probability. So you cannot have an improper fractional probability and a mixed fractional probability. Things to do with 1 1/2, 2 1/3, meaning a whole number and a particular fraction, are not entertained in probability. Likewise, if you have got a numerator that's greater than a denominator, like 9 out of 7, like we'll say 8 out of 3, that's improper fraction. You can never answer probability because, as I said before, probability ranges from 0 to 1, meaning the greatest is 1 as the least is 0. Then the question is, when is probability 0? Probability is 0 when the event will never happen, or when there's no chance of an event happening. For example, if one asked a question like, what is the probability that cow will start flying tomorrow? There is no chance of a cow taking a flight, whether today or tomorrow or in the near future. So because of that, that probability is automatically 0. Then another question will be asked from someone else as concerned, that teacher, when is probability 1? The answer is, probability is 1 in case of a natural event. In case of certainty of the happening of the event, or probability is 1 in case of a natural event. For example, one would be asked a question like, what is the probability that the sun will rise tomorrow? You just know, naturally, God made it like that every day the sun must rise, and so probability will be 1. So things of that nature answer probability as 1. Now, probability itself is given by this formula, number of events out of number of sample space. Number of events out of number of sample space. There are several other formulae that you find in the books. Like in our book, you have probability equals number of expected chances out of number of sample space. Please, it's also correct. Another one says probability equals desired chance or chances out of sample space. It's also correct. Another one says probability is equal to desired chance or chances out of total chance. Is also correct. So I chose to use number of events out of number of sample space, which is an alternative formula to the other ones that you will ever find. And now we are looking at several examples, among which is number 1 that reads, in a box there are 6 green mangoes and 3 yellow ones. In a box there are 6 green mangoes and 3 yellow ones. Then the question about probability says, find the probability of picking a yellow mango at random from that same box. Here we have got 2 colors, that is green and yellow. The green ones are 6 in number, as the yellow ones are 3. You will find out that the total number of mangoes in this box is 9. That's the combination of 6 and 3 together, 9. And now that the question identifies yellow between the 2 colors of green and yellow, you must know how many yellow mangoes are contained in this same box. There are actually 3. Now, number of events is actually got from the very question, like find the probability of picking a yellow mango. So when they say yellow, identify that yellow to be the number of events, whereas the number of sample space means the total number in the given data. So what do you do then to get the number of sample space? You add 6 and 3 to get that 9. So you start probability is equal to number of events out of number of sample space. Like I said before, the yellow ones being 3, you say number of events is equal to 3, and then number of sample space is a combination of whatever in total is contained in the said box. So that is 6 plus 3, so that number of sample space is equal to 9. And being that probability is equal to number of events divided by number of sample space, where the number of events is 3 and the number of sample space is 9, then probability equals 3 out of 9. Remember, much as we are accustomed to reducing, probability is better not to be reduced. So it's better not to reduce the probability, leave it in its infinitive form or original form, leave it as 3 out of 9. We know we are good at dividing, and we know table 3 well, like 1 will divide by 3, either side that's up and down, and guess a third. Please, I urge you to leave 3 out of 9 as it is, and that will be the best probability. When you ask for chance, they will say you find the chance of picking a yellow mango at random from a box. You just replace that word probability, or this word probability, to chance, and when you ask for chance, therefore you say chance equals number of events divided by number of sample space. All in all, use the word chance. Whatever probability is, you will get 3 out of 9 still, but use that very word that has been used. If they use probability, use probability. If they use the word chance, you still use the word chance, where probability would be written, and then get the answer as 3 out of 9 as well. So that's the first example that you use to answer questions in your workbook. from page 26 all the way to page 34, which I know you are following. Then we look at example number 2 about the same probability. This time round we have got certain data given, not counted. Let's see how you actually work out a number where a particular list has been given to you and it reads from the numbers 7, 3, 4, 5, 1. What would be the probability of choosing a 5 at random? The question reads, from the numbers 7, 3, 5, 4, 5, 1, what would be the probability of choosing a 5 at random? Now, wherever they list in a way like this one, please, in your working, you first also list, then choose out the particular sector the examiner wants you to identify. So write 7, 3, 4, 5, 1. But now the probability asked is about choice of a 5 at random. You must note that random selection is when somebody picks things from a particular container without necessarily looking into that container. So just put your hand inside a particular container and pick out without identifying which one by sight, meaning you don't look into that container. So when you pick at once, then that is random selection. So we are obliged to looking at how many 5s are contained in the given data. So having listed like it has been listed up, identify through ticking. That's why 5 has been ticked here. So this means identification of the same event. So you find out among all, I've got a single 5. That's why anyway, it's the one we have ticked. It's the one the examiner has selected out by saying what is the probability that a 5 is picked randomly. So we have picked out a 5, that's how I've ticked it out among the many numbers. And it should be noted that in a setting like this, you count these members in singles, not by addition like we did in number 1. In number 2, we shall count 7 as a member, that is his name, not 7 as in numbers, that there are 7 members. No. We have got only one member called 7, another one is called 3, another one is called 4, another one 5, another one 1. So the members we have are 1, 2, 3, 4, 5. And therefore that makes the number of sample space to be a 5. Please don't add wherever they list in a bit to ask you for probability. Please count the members as they are and they stand their names without necessarily looking at the content in the number itself. So among the 5 members, we have got one member who is called 5, and therefore the number of events will be only 1. And as I said before, the number of sample space is got by counting this time round, not actually addition that we saw in number 1. So you will start like this. Probability is equal to number of events out of number of sample space, whereby you've got number of events as 1, meaning a single 5, and then the number of sample space, you count these members as I said, in like 1, 2, 3, 4, 5. So number of sample space is equal to 5, and so probability is equal to a 50th or 1 out of 5. And that's all. Remember not to add anything here, but please count the members as they are listed there. Before we look at part B, that reads, from these numbers, as you see them, what would be the probability of choosing two numbers whose total is 8 at random? What would be the probability of choosing two numbers whose total is 8 at random? Now, we are using the same data here. You are going to get a total of 8 using these very numbers. Let's see when we combine, we see which one. 7 plus 3, 1 gets 8. No, we never, that's a 10. Then 7 plus 4 is already 11, doesn't qualify. 7 plus 5 is already 12, no. Then 7 plus 1 is an 8, it qualifies. So in your working, identify that same combination of two numbers that total up to 8. So the first one is 7, 8 as the first qualified member within the event of totaling up to 8. Then we go, 7 has been combined with each, and now only 1 has qualified to make a total 8, that's 7 and 1. Then we go to 3. 3 plus 4 is the 7. Never is it 8 then. We go combine 3 with another. 3 plus 5. 1 gets 8, indeed. It qualifies as 1 other on top of 7 and 1. So 3, 5, that's another event among the events. And then we continue to say, we have said 3 and 5, now 3 and 1. So 3 plus 1, you get 4, it's not an 8. Now doesn't qualify, then you go 4 plus 5 is a 9, doesn't qualify. Then 4 plus 1 is a 5, to never. Then go to combining 5 and 1, that's a 6. So all the two have made a total of 8, that is 7 and 1, as well as 3 and 5. So the number of events, we shall have only 1, 2. Then sample space number remains the same. So list the data given wholly, meaning the whole of it, without skipping any. That is 7, 3, 4, 5, 1. And then there will be 1, 2, 3, 4, 5. It will be the number of events. So we start to answer that question and say probability is equal to number of events divided by or out of number of sample space, where the number of events is 1, 2, so it is 2. Then number of sample space, the remaining 5, count them again, 1, 2, 3, 4, 5. So write the number of sample space as 5, thus the writing probability equals 2 out of 5. Be careful about such questions. Before we look at part C, connected to the same question, number 2, that says from the numbers, those ones, what would be the probability of choosing as 6 at random? That would be the probability of choosing as 6 at random. Okay, still list the whole data again, that is 7, 3, 4, 5, 1. Identify a 6 if you can see it. Then you have got a better sight than the teacher, but I cannot see any. Therefore, there is nothing like a 6, and therefore you cannot tick any. So first list to identify. Now we don't have any 6. We continue. It means there is no chance. So therefore, the number of events will not be same. It will be 0. Then the sample space number remains the same. So we say probability is equal to number of events out of number of sample space. As you have seen, there is no 6 at all. You say number of events is equal to 0. Whereas number of sample space is equal to 5. So you count these ones. And then say probability is equal to 0 out of 5. And remember, there is no fraction that will ever remain in this way. So we say probability is equal to 0. Therefore, we don't have any chance of having the 6 selected at random from the said numbers. In that way, you have answered that. And then you go to part D, which is connected to number 2. Again, it says from the numbers, these very ones, what would be the probability of choosing a 7 at random. So still list 7, 3, 4, 5, 1. Tick 7 because it is the one in the question and it's only one among the events, and then the number of sample space remain 5. Thus you say probability is equal to number of events divided by number of sample space, or out of number of sample space, where the number of events is only 1 7 there, and then number of sample space remains 5 to get probability as a fifth. In that way, you'll be able to answer questions that are related to given listed data to identify probability in that order. Of James going to Kenya on a day that starts with the letter T. Find the probability of James going to Kenya on a day that starts with the letter T. As you know, right from P1, that 7 days make a week. Therefore, we must know that already automatically shall we have the number of sample space to be 7. But again, remember, I used to say list them, and you jumped Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and teacher used to several say 7 days, and we shouted, make a week! And now they are here to be applied in probability. So list all the sample space here by writing the contractions from those words, Sunday up to Saturday. You are free to start with Monday, but the English calendar calls for Sunday as the first of the week. That's why I opted for starting with Sunday. So this is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And now the question is asking for a day, or this James is going to Kenya on a day, starting with letter T. So identify the days that start with the letter T. The first one is Tuesday, tick. And then Thursday, tick. The rest are not starting with the letter T. So meaning the number of events will be 1, 2. So that will be the number, that is 2. Then the numbers of sample space will be 1, 2, 3, 4, 5, 6, 7, like you count it right from P1, that 7 days make a week. It hasn't changed even P.6, please. It is still P, still 7 days that make a week. So that the number of events is 2 and the number of sample space is 7. So we'll start that probability is equal to number of events out of number of sample space. And then you say number of events, the letter T, or the days that start with the letter T have been 2. That is 2, then the number of sample space, those 7 days, so it's equal to 7. Thereby getting probability is equal to 2 out of 7. And that we have answered that question before we go to finding probability from a Venn diagram as the next sub-topic. We are going to look at how one can identify the number of events as well as the number of sample space from a drawn Venn diagram. And that's what we are going to look at now. Finding probability from a Venn diagram. Finding probability from a Venn diagram. And the first example about how one can find the probability from a drawn Venn diagram reads. The first example reads, the Venn diagram below represents the number of sets, that is x and y. As you see, we have both set x and y, and now you are asked to calculate the probability of choosing a member in x intersection y. Calculate the probability of choosing a member in set x intersection y. Now look at the Venn diagram drawn properly. As we did in the previous sessions, we said part shared by 2 or more different sets is the one we term as the intersection of the 2 or more sets. And therefore, this is the sector where 7 is, termed as x intersection y. And now that here I've got a number of elements set X and the number of elements set Y, and that I've got this universal bracket, these are actually standard numbers. They are not singles. There are 7 members in the intersection of X and Y, not 1 like we have seen before. This is the number of elements in set X intersection Y, which will make the number of events, because it is the sector talked about X intersection Y. You go directly to that same sector of the Venn diagram and then identify the number of events to be 7, like in this case. So had they said X only or X take away Y, you would use 4. Likewise, Y only, you would use 3. If they had said set Y or number of elements set Y, you would use 10. And if one had talked about number of elements set X, you would choose 11. But now that they are saying X intersection Y, and the number of found the intersection of X and Y is 7, it will make the number of events. And it actually stands this number not being 1. No, there are 7 members in the intersection of X and Y. And then the number of sample space will be an addition of all these that are contained in the Venn diagram. That is 4 plus 7 plus 3. Never, please, never should you add the upper numbers. The already sums, please don't sum the summed upper numbers already. Add these ones that are still in their infinitive form or original form. Therefore, add the 4, 7, and 3 to get a number of sample space. That's why you start to respond to that question. Say probability equals number of events out of number of sample space, where the number of events is 7. Please, those members in the intersection of X and Y are 7. They qualify to be here. And then number of sample space, as I said before, add whatever is contained in set X and Y. Please inside. That is 4 plus 7 plus 3, which 4 plus 7 is already 11, and 3 added to that you get 14. So number of sample space is 14 to get probability as 7 out of 14, as easy as that. So please identify the same sector for which the probability must be formed. And then the number of sample space means the whole content or the whole container. The content of the whole container. Please, you add whatever is inside, and then get the answer. Mathematics is very easy, that is, if one followed and then practiced. But if you don't practice, then it will be the hardest, like I hear people say, it's the hardest. Why is it the hardest? Because they have hard hearts towards mathematics. They are hard-hearted, in short. Please be soft-hearted in mathematics, meaning soften the heart and follow the teacher. Love the teacher, love the subject. Practice regularly. You will be able to answer successfully. Before we look at example number 2, about how one can find probability from a given Venn diagram, you see it here. And number 2 reads, in the Venn diagram below, calculate the probability of choosing a member from set B. Calculate the probability of choosing a member from set B. As we did in the previous 2 sessions, we identified what is called set B, what is called B only, what is called set C, what is called C only, what is called universal, and the rest. Now, 1 is asking for a bit of choosing a member from set B, which set B is the whole of the circle. Is the whole of the circle. So it contains 6 members as well as 3 members. So therefore, set B in total contains 6 plus 3 members, which 6 plus 3 is actually 9. So number of elements set B, as talked about up, is 9. That will be making the number of events today for this particular number. As I said before, number of sample space is the summation of whatever is contained in the Venn diagram. Summation means totaling them up. Please sum them up. That is 6 plus 3 plus 7 plus 2, Don't forget the 2. You can even start with this, that is 2 plus 6 plus 3 plus 7, and then get a number of sample space. Hence, you say probability is equal to number of events divide or out of number of sample space, and you say number of events are those elements that are contained in set B. So that's 6 plus 3, which you write here, making the number of events as 9. Then number of sample space, you sum up all these, that is 6 plus 3 plus 7 plus 2, where 6 plus 3 is a 9, and you say 9 plus 7, one gets 16, and the 16 plus 2 you get 18. So the number of sample space is 18. And now that probability is equal to number of events equal to, so out of number of sample space, and the events number being 9, and the number of sample space being 18, then probability is equal to 9 out of 18. And so doing, we have answered. Remember, not reduce probability even if it's reducible. Don't reduce the probability even if it's reducible. All fractions must be reduced apart from probability, square, square root, and reciprocal. So all those will involve fractions, but leave them as they are. So among those you must not reduce is probability. So don't reduce probability. You will be a successful semi-candidate as you are now. Now that you have been a good audience, I will still ask you to lend me your ears, as you lend me your sight as well, as we look at number 3 that reads, in a class of 30 pupils, 18 eat gorillas ghee. Somebody's happy because I've mentioned gorillas. This is what is happening in the other class, not yours. So, in a class of 30 pupils, 18 eat gorillas ghee, 20 eat bagia bee, 3 do not eat any of the 2, that is gorillas, and neither they eat bagia, while Y eat both. And now the question says, find the probability of choosing at random, please, a pupil that eats both gorillas and bagia. A pupil that eats both gorillas and bagia. Now that the Venn diagram is filled for us, on depending the universal set, number of elements in the universal set, which is equal to 30, that universal will help us get the number of the sample space. Actually, the number of sample space is that already. And now they are saying find the probability of choosing at random a pupil that is both gorillas and bagia. So we shall learn that both gorillas and bagia is a sector termed as the intersection, which intersection contains Y, meaning there is a necessity to find the value of Y, which we shall later name as number of events. So therefore, given that the Venn diagram has been drawn for us and filled successfully, we identify the intersection to be Y, which Y is not a number yet. Then let's get a value of Y. That's why the first heading here says value of Y. When you get a value of Y, it will be those said pupils that eat both gorillas and bagia that we are finding the probability for today. So we say value of Y. As we said in the first lesson, we add whatever is inside to the universal. So we say 18 minus Y plus 20 minus Y plus 3 is equal to 30. That's the step here. Before we collect like terms, put the Y's together and those without Y's. I chose to start with these ones that don't have Y, then Y is later. So we go 18 plus 20 plus 3. Ensure you maintain the signs that are written before any figure. I say you say 18 plus 20 plus 3. Then go to our Y's. Plus Y minus Y minus Y. We start with this one that's got a plus Y minus Y minus Y. This is the statement which remains to be equal to 30. So we are going to simplify the right terms through doing what has been instructed us to do. We have been instructed to add here, so do we add? We say 18 plus 20, which makes that 38. 38 plus 3, 1 gets 41. That's why you see 41. And well known it is that y minus y is 0. So therefore this one goes away. We all remain with minus y. That's why the next step is 41 minus y is equal to 30. 41 minus y is equal to 30. Now, in the other lesson, you say whenever you're given a minus, you add that even number to either side. That's why the next step says 41 minus y plus y is equal to 30 plus y. And then again I said when a minus is a plus, we interchange and the plus instead does the leading. So therefore we say instead of minus y plus y, we say plus y minus y. That is 41 plus y minus y is equal to the same 30 plus y. So we know now y minus y is a 0, and therefore we can then interchange what has been this side, and then 41 goes the other side. So that is 30 plus y is equal to 41. 30 plus y is equal to 41. And now we identify 30 to be a positive integer, and we say spoiling or doing the opposite of a positive is introducing a negative. So we are going to subtract 30 from both sides, thereby remaining the y value. So we say the same 30 minus 30 as it is here, plus that y equals 41 minus 30, where 30 minus 30 is 0. Now gone it is, then remaining y, which is equal to the difference between 41 and 30. When computed very well, you actually get 11. That's y is equal to 11. But remember, the question is about probability of choosing at random pupil that eats both gorillas and bagia. And now, in the Venn diagram, it is represented by y, which y value we have successfully got as 11. And therefore, that will make the number of events. And the number of sample space is the total number of pupils in a class, which happens to be 30. And then start to answer the question. As you say, probability is equal to number of events out of number of sample space, which number of events is 11, because 11 pupils eat both gorillas and bagia. And then number of sample space, it means the whole class population of 30. So number of sample space is equal to 30, and so probability is equal to 11 out of 30. In so doing, you have learned how to identify particular sectors in terms of number of events and number of sample space from the Venn diagram, whether drawn or asked to draw. Because one may tell you to draw and then find a probability. Now these are drawn for you to just identify the said sectors in terms of number of events and number of sample space. And so doing, you are good semi-candidate and you make a very good candidate next year. That is CAM P7. Now, this is Teacher Katimbo that has taught you this set concept about probability. For more information about the same or mathematics in general, you will call Teacher Katimbo on 0776 251655. If not that, you use 075 72 33 066. And this work will be found on page 26 all the way to 34 of your workbook. And every kind of query you need to answer that work has been answered here. And remember, COVID is real. Therefore, one must put on this mask wherever it goes out to the public. Otherwise, stay safe.